Hello there, I am Ms. Page, and this lesson is going to be part of our unit on solving radical equations. Specifically, this is a lesson devoted to solving equations that involve rational exponents. We have seen some problems, the square root equations and the cube root equations, simple ones that have been in rational exponent form. Here we're going to see more complex ones as shown here, where there's more than one rational exponent within the equation, or whole number powers mixed with rational. We're looking at binomial structures and trinomial structures, and we'll learn that we can treat these like we have other binomial and trinomial structure equations and use our skills of factoring to create a product of factors and then use our zero product property in order to find the solutions. As with other types of equations of this type, they can have extraneous solutions. So we definitely do have to check to see if our solutions are valid. Here we're looking at a couple rather simple equations with rational exponents. Both of these we have seen in our other lessons, but not written in this format. So the first one here is simply, this is the same thing as the square root of x equals 3. I'm going to go ahead though and solve it in this particular structure rather than change it to its radical structure to show you that it's very doable in this form also. So basically what we are doing here is that reverse order of operations when we're solving using our algebra skills. We're at the point where we're going to undo this exponent. And to undo a single power like that, what we need to do is raise both sides to the appropriate power. The appropriate power, you need to understand, would be the reciprocal of this power, because anything times its reciprocal is 1. And x to the first power would then be x, and that gives us an x equals answer, which is what we need. So that would be 2, the reciprocal of 1/2 being 2, and so this gives us x to the first power, which is of course x, and 3 squared is 9. And then for checking purposes, you can use this structure here, or you can change it to its radical structure. I'm going to again show you how to use this structure for a check, okay? So what we'd have would be 9 to the 1/2 power equals 3. So, like I said, you could change this to the square root of 9 and see that you get 3 equals 3. Or you can rewrite 9 as a power, such as 3 squared. And that would be 3 squared to the 1/2 power equals 3. Again, we're checking technically if that's true. And 2 times 1/2 again is 1. 3 to the first power is 3. So you get 3 equals 3 this way also, which tells us that 9 is a valid solution. Similarly, with the second problem here, we're undoing an exponent of 1/3. So the appropriate power we want to raise both sides to would be the reciprocal of 1/3, which would be 3. And then we have 1/3 times 3, which would be 1. X to the first power is, of course, x. 3 cubed would be 27. And then checking that, again, we can check either by changing you can change this to a cube root if you would like to, but you can also check it by rewriting 27 as a power. In this case, it would be 3 to the 3rd power. So you're looking to see, is that going to be 3 to the 3rd power to the 1/3 power? 3 times a third is 1. 3 to the first power is 3. So you get 3 equals 3. And that makes 27 a valid solution. Like so. For the third example of this particular type, where we have a simple power of x, where we have a rational exponent equals a number, we are going to look at this one. So here we've got a numerator that is a value other than 1. But the procedure, you have to realize, is the same. We need to undo this exponent. So we need to raise both sides of our equation to the appropriate power. And again, our goal is to get to x equals, which would be x to the first power. So that appropriate power we raise both sides to needs to be the reciprocal of this exponent, 3/2, which would then be 2/3. So over on our left, 3/2 times 2/3 would be 1, because any number times its reciprocal is 1. X to the first power is again x. Over here, we have a little bit more work to do. So our 8 to the 2/3 power, we have to realize gives us the cube root of 8, and then that would be squared, our power of 2. The cube root of 8 is 2, that gives us 2 squared, which gives us x equals 4 as a possible solution. So then checking this one, I'm looking at 4 to the 3/2 power, is that equal to 8? So again, I can rewrite this as a root. This would be the square root of 4 cubed. Or I can change 4 to a power, which I'm going to show you that strategy. 4 would be 2 squared. So this would also be 2 squared to the 3/2 power. And we'd multiply the 2 and the 3/2, which would give us 3. Either you can look at it as 6 divided by 2, or you reduce your 2's to 1, and 1 times 3 is 3. But basically what you have is 2 cubed, and 2 cubed is indeed equal to 8. So that makes 4 our valid solution, like so. All right, so now we are going to talk about equations that have a little bit more complex structure. They have more than one rational exponent. That's what this with multiple rational exponents. They come in either a binomial or a trinomial structure. So we want them in standard form, which is what this is saying here, having our equation equal to 0 on one side. We're going to use our factoring skills to factor the expression. And generally that will be a GCF for binomial structures, and into two binomials when we have a trinomial structure. Once we have that product of factors equals 0, we then always use our zero product property. Then we'll do basically what we were doing on the previous problems, because we'll have an equation that will be similar to those. So we'll solve for x using our algebra skills, and then again check for extraneous solutions. We've got to make sure that they work. All right, so let's take a look at this problem. So here what we have is a binomial structure with two powers of x. So we basically would solve this one the same way we would solve equations such as x cubed minus 2x equals 0. What we do here, remember, is our numbers here, their common factor is 1 because this is a 1. But we use the smallest power of x as our common factor for the x's. We do the same thing here. So the smaller power of x is what we're going to factor out. And 1/2 is smaller than 3/2. So this is what we're going to factor out of that binomial. And so this part's fairly easy. We know that's going to be a minus 2 because the negative 2 times the x to the 1/2 gives us minus 2x to the 1/2. This one, you got to use your exponent property because you have to figure out what power of x times x to the 1/2 gives you x to the 3/2 power. So remember, you are trying to figure out, according to the exponent properties, what plus 1/2 will give you 3/2. So you should realize, okay, well that then is going to be 2/2 because 1/2 plus 2/2 would be 3/2. Well, what is 2/2? That is 1, which means that this needs to be x to the first power, or just x. So we're looking at this being our factored form. Then we have a product of factors equals 0, so now we use our zero product property. So either our GCF factor of x to the 1/2 is equal to 0, or our binomial factor of x minus 2 is equal to 0. This one, similar to what we had before, I can raise both sides to the power of 2, which is the reciprocal of 1/2. In this case, 0 to any power is 0, of course, so this gives us x equals 0 as a possible solution. And over here, adding 2 to both sides gives us x equals 2 as a possible solution. So now I want to check and make sure that they're valid. I want to check in my original equation here. So if I'm going to check x equals 0, I'm looking at 0 to the 3/2 power minus 2 times 0 to the 1/2 power. Is that equal to 0? So as I was saying, 0 to any power is going to be 0. So this becomes 0 minus, and 2 times 0 is 0. So yeah, 0 is good. It'll work. Now let's look at 2. So now what I'm looking at, 2 to the 3/2 power minus 2 times 2 to the 1/2 power. Is that equal to 0? And so here what I would be looking at, because 2 I can't rewrite as any other power, I'm going to look at this in terms of combining my exponents. So this is 2 to the first power. These are both powers of 2, a product of 2 powers of 2. So the exponent property says I can combine those by adding those exponents together. And 1 plus 1/2 is 1 1/2, and 1 1/2 is 3/2. So what I have is 2 to the 3/2 power minus 2 to the 3/2 power. And anything minus itself is indeed 0, which means 2 works also. So our solutions, in this case, both x equals 0 and 2 are valid solutions. All right, we're going to look at another example now that is a binomial structure. Go through the process again, kind of emphasize this. So when we have a binomial structure, we're looking at factoring out the smaller power of x. If it's in standard form, it will generally be the second power, but always verify. So 1/3 is smaller than 2/3. So this is the power of x we're going to factor out. And this will give us x to the 1/3 then times in parentheses equals 0. And again, this part's the pretty easy part. This is going to be plus 4, because 4 times our x to the 1/3 is 4x to the 1/3. We also need to figure out what this power of x needs to be. So again, what we're using is our exponent properties. We have x to the 1/3. We want to figure out times what power of x would equal what we're starting with, which is x to the 2/3. And the exponent property here is addition. So we need to figure out, well, 1/3 plus what equals 2/3. So we should realize that's going to be 1/3. 1/3 plus 1/3 is 2/3, which means this needs to be x to the 1/3. So now we have a product of factors equals 0. So now we'll use our 0 product property. So either our GCF factor of x to the 1/3 equals 0, or our binomial factor of x to the 1/3 plus 4 equals 0. Over here, I'm going to undo this exponent. So I'm going to raise both sides to the power that's the reciprocal of 1/3, which is 3. And again, 0 to any power is 0, so I get x equals 0. Over here, I have to undo the addition first, which gives me x to the 1/3 equals -4. Now I'll undo the exponent, raising both sides to the reciprocal power, which again would be 3. And so I get x here, and -4 to the 3rd power is -64. So these are my two possible solutions. So now I need to check them. So checking 0, what I'm looking at is, so again, I'm going to use my original equation here. 0 to the 2/3 power plus 4 times 0 to the 1/3 power. Does that equal 0? Again, 0 to any power is 0. And so this becomes 0 plus 4 times 0 would be 0, and 0 plus 0 is 0. So 0 is good. Looking at -64. So now I'm looking at -64 to the 2/3 power plus 4 times -64 to the 1/3 power. Is that equal to 0? Now, you can do this one with rational exponents, but you have to realize that when you're dealing with a negative base, that negative base then needs to be in parentheses. So what I'd be looking at here would be, okay, I have this -64 would be -4 to the 3rd power. And then I can say, okay, 3 times 2/3 would be 2, and then negative 4 squared would be positive 16. And then this would be negative 4 cubed. 3 times 1/3 would be 1. So that gives me negative 4 times 4, which would be negative 16. And I get 16 plus negative 16, which is 0. So that's one way, which looks like this. So you've got this is cubed to the 2/3. That's 2. Negative 4 squared would be 16. This would be negative 4 cubed, and that's to the 1/3. 3 times 1/3 is 1. That's negative 4. Negative 4 times 4 is negative 16. I'm just going to write it out. Let's change that. And so that is 0. If you get a little lost in that math because you haven't had a lot of practice with doing it that way, you can change it to its radical form and make it the cube root of negative 64 squared plus 4 times the cube root of negative 64. Check to see if that is 0. Again, this would be negative 4 being squared, which would be 16. This would be 4 times negative 4, which would be a negative 16. And see that you get 0 that way. Either way, they are both perfectly fine. So our two solutions, we have two solutions this time, negative 64 and 0. All right, so now we're going to take a look at an example that is a trinomial structure. All right, so similar to our binomial structure, our trinomial structure we treat as a quadratic structure and factor it into two binomial factors. So we would factor this similar to how we factor x squared minus 5x minus 6 equals 0. That the two factors we would use for our first power of x are actually powers of our middle power of x, and that's how this works also. So the factors of x to the first power that we will use will both be x to the 1/2. And this will then give us two binomials where we'll have x to the 1/2 and x to the 1/2. The product of those, remember, would add the 1/2s together, which gives us 1. And then two factors of negative 6 to get our negative 5 would be a negative 6 and a positive 1. So now we have negative 6 to the 1/2 plus 1 to the 1/2 gives us negative 5 times x to the 1/2 power. And so now we have a product of factors. We can use our zero product property. So either x to the 1/2 minus 6 equals 0, or x to the 1/2 plus 1 equals 0. So going back to this first one, I'd have to undo the subtraction first, adding 6 to both sides. Then I would undo the exponent, raising both sides to the reciprocal power, which would be 2. So now I get x equals 36 as a possible solution. Over here, I'd have to undo my addition first, subtracting from both sides. So I get x to the 1/2 equals negative 1. Then I would undo the exponent, raising both sides to the reciprocal of 1/2, which is 2. And here I get x equals, and negative 1 squared would be negative 1 times negative 1, so it's positive 1. Now I'm looking at checking each of these. So I'm going to check in that original equation where I have my trinomial. So this is x, this would be 36 minus 5 times 36 to the 1/2 power minus 6 equals 0. So there are a couple of ways you can simplify this. You can think of this as 6 squared. 2 times 1/2 gives you 1, so this is going to become 6. You can have also, of course, just look at that as the square root of 36, which is 6. So this is 5 times 6, which gives you 30. So we've got 36 minus 30 minus 6. And we want to know, does that equal 0? Well, left to right, 36 minus 36, 6 minus 6 does give us 0. So 36 is good. looking at the positive 1. Okay, so we'd have x, which is 1, minus 5 times x to the 1/2 power, so 1 to the 1/2 power minus 6. Does this equal 0? So again, this right here is the square root of 1, so that's 1. 1 times 5 is 5, so we get 1 minus 5 minus 6. And left to right, 1 minus 5 would be negative 4, and negative 4 minus 6 is negative 10. And that is not equal to 0. So it turns out 1 is an extraneous solution, and we throw it out. So our only valid solution turns out this time to be the 36. All right, one more example of this particular type. We have here another trinomial. This time we've got two fractional exponents. So again, it's a trinomial structure, and we would factor this into two binomials. Again, the factors we would use for x to the 2/3 will need to be powers of our middle power of x, x to the 1/3. So, and you'll see that the math works because we have x to the 1/3 here and x to the 1/3 here. So when we multiply those powers of x together, the exponent rules say we add the exponents, and 1/3 plus 1/3 is 2/3. Then we need two factors of 3 to get our positive 4, would be a plus 3 and a plus 1. So now we're going to use our zero product property. Checking the middle, by the way, we'd get 3x to the 1/3 plus 1x to the 1/3. We can see we're going to get 4x to the 1/3. So it's back to zero product property. So either x to the 1/3 plus 3 equals 0, or our x to the 1/3 plus 1 equals 0. So back over here at the left, we would undo the addition first, and that would give us x to the 1/3 equals negative 3. Then we'd undo the exponent, raising both sides to the reciprocal power, which would be 3. This gives us x to the first power, which is x, and negative 3 times itself 3 times is negative 27. Then here, undoing our addition here first, we get x to the 1/3 equals negative 1. Undoing the exponent, we raise both sides to the reciprocal power, which is again 3. Here we get x to the first power, which is x. Negative 1 times itself 3 times is negative 1. So that's another possible solution. So now we're going to look at checking each of those to see if they are valid. So I'm going to use this original equation again. So I have negative 27 to the 2/3 power plus 4 times 27 to the 1/3 power plus 3. Is that equal to 0? So again, you can look at this as negative 3 to the 3rd power, and 3 times 2/3 gives you 2. Negative 3 squared is 9. Or you can use your radical form and look at it this way. So here you get negative 3 squared, which is 9 also. You can look at this as 3 cubed to the 1/3 power. 3 times 1/3 is 1, so this becomes 3 times 4, which is 12. Or, again, you can look at this as 4 times the cube root of 27, which is also 4 times 3, which gives us plus 12. And then we have plus 3. And is that equal to 0? Now here at this point, I'm looking at this going, okay, that does not give me 0. And I might be inclined to think that, okay, that means that negative 27 is invalid. However, we've talked about with cube root equations, extraneous solutions are very unusual unless we end up with something that involves our imaginary unit of I. And given my powers here, these are both cube roots. And so then I start thinking, okay, did I make a mistake with my math? And in looking over my check, what I discover is that I used the correct value of x here of negative 27, but I did not here. I used a positive instead of a negative. So this is actually the cube root of negative 27, which is a negative 3, and negative 3 times 4 makes this a negative 12. So So either minus 12 or plus negative 12. And then I'm like, okay, now this makes more sense, and this is actually a valid solution, the negative 27. So keep that in mind as you're going through with your cube root equations, just like with our previous ones. Only I situations or solutions that involve i's is where we see those extraneous solutions. So here I'm more checking for the accuracy of my algebra up here. Same thing here. So I would expect this to check, but again, if I have made any mistakes, this is a good way to catch those mistakes. So looking at this, is this 0? So this would be the cube root of negative 1 squared. And the cube root of negative 1, what times itself 3 times equals negative 1 is negative 1. Negative 1 squared is 1. And then this gives me 4 times the cube root of negative 1. Get my sign right this time. That's negative 1 times 4, which is a negative 4, plus 3. And that gives me negative 3 plus 3, which is indeed 0. So negative 1 is also good to go. And so our solutions are negative 27 and negative 1. All right, so those are all of the examples, a few of each type, and now you should be ready to begin your assignment. Have a good day.